Welcome to TFR Let's Talk. I'm your host, Swapnil Bhartia, and my next guest is Shahar Fogel, CEO of Rookout. Shahar, it's great to have you on the show.
Pleasure to be here, and thanks for inviting me.
Just to tell our viewers, we have actually covered Rookout before, but I want to hear from you. Can you tell me quickly an elevator pitch? What is Rookout all about?
So basically, in Rookout, we developed a platform that enables engineers to get the data they need from remote environments in a click of a button. So to be able to debug their applications in remote distributed environments and also production environments without the need to write more code, without the need to wait for redeployments, and without stopping the normal performance of the application. So just click a button, get the data you need from the application, understand what's going on, fix it, and move on.
What is the importance of observability, debugging, and also one of the focus area for today's discussion is going to be understandability. So let's talk about first of all how would you define understandability, and then let's talk about the importance of observability in general.
Cool. So basically, you mentioned observability and understandability, which is two complementary areas to the software development lifecycle. So if you think about observability, what it helps you and all the observability tools is to observe the application, to observe the infrastructure, to understand kind of in high level what's going on, and they're very good in finger pointing around issues or spikes or bugs or crashes or what have you in the life cycle. But essentially, when they end, we begin. So when the observability tools point you to some direction, they give you the blessing and tell you, go understand what's going on and fix it. And this is kind of where the understandability space comes into play, where tools like Rookout or other tools in the space enables you to get to the root cause of the issue, understand what's really going on in the application in a click of a button or in a very short amount of time, to get to the resolution, the root cause, and solve it quickly, reducing MTTR, reducing the clients and the business which are shouting at the engineers, what's going on? We need it fixed. My deal is blocked. I have a renewal. Why is it not fixed? So all these issues that comes into play. This is the understandability space. So to understand what's going on quicker. You've mentioned kind of observability and understandability in the cloud native environments and also debugging. So if in the past we as engineers used to write code, do everything on our local machine, make sure that it works, and then push it to production or to pre-production staging, whichever environments today in the cloud native world, the distribution and the architectures became much more complex. The engineers are writing their batches of code, pushing it to the CI/CD, and it's gone. They don't know where it's going to. They don't know the distribution because Ops is managing it, where it's deployed, which pod, whatever. And when they need to actually debug something or understand something, it's very complex for them. They don't have the visibility to all the pods. Some companies have thousands of servers and instances which are running, and for them to pinpoint the exact location or the exact issue, it's very complex on one end, and it's almost impossible to reproduce it on their local machine because you can't really simulate a Kubernetes cluster on your machine.
And you mentioned that understandability starts after observability, where observability ends. Now, when we do look at observability, what is happening is that we are collecting just too much data, too much metric, whatever is there. Now, that data has no value in itself. The value is what value you extract from the data. So can you also talk about if there is a playbook, hey, these are the areas where you should collect just because you're running a big stack, collect everything. It becomes too complicated.
Yeah, so of course, every company, every enterprise, every dev organization with their own methodologies of what to collect, how to observe. Some just thinking about logging FOMO or APMs, they collect everything. They see everything. Everything goes into their Elastic or Splunk or whatever, and then there becomes a lot of noise there. So in terms of kind of my recommendation is collect what you need to collect for the most basic elements of understanding or collecting metrics that are relevant to your application. Collecting too much becomes noisy, of course, super expensive. If you're thinking about logs and these sorts of solution, not only expensive in terms of costs from the vendors, but also expensive in terms of driving, as you mentioned, driving the actual insights from all the noise that is coming in and kind of pulling the needle from the haystack. So, if you think about the existing world of observability, all the instrumentation there is being done statically, predefined areas where you want to collect the metrics from. But the understandability tools enables you, like Rookout, enables you basically to do it dynamically. You don't have to predefine everything. You can deploy it. You know that you have Rookout there as an on-demand tool, and we enable dynamic instrumentation on the fly, even in production, to get what you need in that specific second. Use it, collect it, understand, solve it, remove it. That's it.
Do you see what is happening in the space that are users really collecting too much data, or they are well versed, this is not a problem to be solved?
So let's divide the answer into two. One is, as I mentioned before, some enterprises collect too much data. They're logging and logging and logging, which affects cost, which affects, of course, performance of the application. Every log line is another execution of code. Every new deployment is a risk, a security risk, a functionality risk, and to add more and more logs every time just to collect the data you need, time consuming, cost consuming. Meantime, the resolution is high. Some organization, it takes hours or days for each redeployment. So that's kind of one area. The second area is that basically some environments are basically making it impossible for the engineer to collect data from, unless he's really collecting everything he can. Sometimes you want to collect a log line from a specific line of code, but you collected only this variable and not that variable, and you don't see the stack trace, and you don't see kind of all the peripheral or contextual data around it. So again, you need to add more or to redefine what you want, the span or the log or whatever. Again, it's the same iteration. It's the constant iteration that needs adding and adding, whereas you can do it, dynamically, on demand, add it, use it, remove it.
Right, excellent. Now let's move to the second part where you folks enter, which is more or less like we have all the data now. We have to debug the application in the cloud. What are some of the typical challenges? I'm not talking about some rare cases, but common challenges that you see customers face when they try to debug applications, especially in the cloud.
So we see it kind of in two areas. One is the end point of what we call production debugging. So the having the ability to debug on demand on production, it gives the users, the engineers, first of all, accessibility to production environments, of course, with all the security mechanisms and all the safeguards that are inherited within the product. But it gives them the ability to see what's really going on with their clients, to see how they're using, and not to need to reproduce the bug in closer environments or replicate entire databases just to simulate it on pre-production, on staging. It's a big thing when something happened in production. So that's kind of one major use case. The second use case, and when we talk about cloud environments, cloud native, Kubernetes, containers, distributed environments, is also in the software development lifecycle. So as I mentioned before, the small chunks of code goes into a distributed environment. And in order to, this is where developers spend most of their day, in the dev environments, developing new features, maintaining software. And even in these environments, they're having difficulty to access what's really going on. There's no way to really, use traditional debuggers to debug distributed applications. So this is why they need kind of the modern debuggers to enable them also in their day-to-day, instead of waiting, even in agile companies or cloud-first companies that build their infrastructure from ground up in the cloud environment. It takes time. It takes 20 minutes. It takes 2 hours for each iteration, whereas you can do it in a second and save tremendous amount of time for the engineering.
One more thing about cloud is that the things have to be done in real time. Especially, you cannot afford to stop an application. There is no downtime. Business continuity is really critical. You have talked a lot about how Rookout is helping, but I just want to focus on this area, that how does Rookout allow developers to kind of get real time data without affecting the application itself?
I'll answer it and take it a level up, and it's not only about the engineering and the application, it's about the business. The business is the main impact, and when issues arises from the business, whether it's from our clients or the go-to-market team, the sales team, the success team that have issues that gets escalated to engineering, from that second onwards, it affects the bottom line of the company. And if we're talking about business continuity and we're talking about resilience, so most of the people treat resilience as only if the application is on fire or it crashed or downtime, this is resilient. But no, resilience is everything. Even if a customer is unable to use a specific feature, which is blocking a deal, blocking a POC, affecting NPS, affecting expansion or adoption, renewal, everything that is around the business and the application, and something which happens in it, an inability to use something or which is affecting the customer. This is kind of the core of let's call it the modern day resilience or the cloud resilience, not only about major crashes and downtimes, but also about the day-to-day.
Cloud native is a very busy, very crowded space. There are a lot of other players. Initially, as we started this discussion in terms of observability, can you talk about, despite using the same open source technologies, same projects, how do you kind of differentiate yourself from other players, let's say Lightstep or Honeycomb?
So Lightstep and Honeycomb are they're a tracing solution. They're doing what they're doing, and we love them and we collaborate with them. But they're giving you a certain element of observability with traces, of course, and with modern distributions. But again, with a tracing solution, all the spans needs to be predefined. You cannot do it agilely. You cannot do it on demand. You need to predefine what you want to collect, even if you want to collect everything, or but eventually you need to predefine it. What we enable you is dynamically define it, dynamically instrument your code. That's one. Secondly, we enable, because we have access to the actual, process and code level data, we enable engineers to get not only the span data, but, variables data, stack trace, performance data, do profiling on demand. So, if the tracing tools gives you kind of statistical data on the entire application, we enable you to deep dive into the specific function you want, place the non-breaking breakpoint, say, I want to understand what's the performance between this line, and it gives you the exact time measurement. And you want to drill down a bit more, instead of this, I want to measure this, everything that the developer needs on demand in the most granular ability. And of course, without affecting the performance or stopping the application.
If you do look at, you actually explained in the beginning still, but if you do look at observability or debugging, one of the things that in today especially is that security. You can, of course, moving fast is good, being able to push, all your code is good, but security is becoming really, really serious. It's no longer an afterthought. What role does understandability or observability play in the security pipeline as well?
So first of all, it's important to stress that kind of what we're doing and how we're doing it comes from a security mindset. Myself and most of our engineering team and product team come from security background, so that's kind of in our blood. And this is kind of the mechanisms or the ways that we develop the product is from a security perspective. So taking the security tool sets and applying it to the DevOps. So that's kind of dynamic instrumentation and all the things you see in a more security-oriented companies. That's one. Secondly, in the way we build the product, and not only the core capability of dynamic instrumentation, but all the wrapping around it. Two most important things for us when we onboard clients, or kind of to make sure our client know, is one, that we will not affect the performance of the application, and two, security. So making sure that we're super secure, we're not compromising anything, and we have all the mechanisms around it. Of course, we're ISO 27001, SOC 2 compliant, and we have a lot of security mechanisms built within the product. But also, if you think about the challenges that cloud native adds to the complexity of security, what we do is reduce it, because we enable a direct access to the servers, whereas kind of today we're seeing in enterprises they're doing SSH to servers on all sorts of things that compromises greatly the access to the production environments or development environments. And we're saying them, okay, you're an engineer. This is kind of all the data points or metrics that you want to collect. We're giving you the ability to collect it in a very secure wrapping. So we're actually also solving a security consideration when handling in cloud native environment.
If we do look at the whole understandability, observability, and security space, what are the trends that are seeing? I'm just not talking about the trends that are coming from the vendors, from the ecosystem, but adoption in the market, because 2020 was a year when a lot of companies, because of this pandemic, were rushing towards cloud native. They were rushing towards digital transformation. Now they are settling down, and then now they're realizing that, hey, you know what? Moving to cloud is easier, but as you earlier said, day two is where the real problem, real challenges start. So now they are facing all the challenges, all the roadblocks. So what are the trends that you're seeing in the market, which could be a kind of compilation of from the users, from the vendors, from the open source project, from the ecosystem?
So there's many trends that happens over the last let's call it year or so, a bit more even. And kind of we've seen 3-4 years process happens within a year, because of remote work, because of the cloud native adoption, because of the understanding of even more traditional enterprises which are coming into the cloud. We're working with banks that if you have been, you would have talked to them a couple of years ago, they would have told you, on-prem or nothing. And today there's much more adoption in the cloud. But in terms of kind of, let's call it development methodologies, so we're seeing that engineering managers, directors, VP R&D, CTOs put a lot of emphasis on quality of code, velocity of development, measuring much more KPIs that are relevant to the cloud and how they're managing it, how to manage the relationship between ops and engineering, people talking about the shift left motion and giving more powers to engineers to do, to do their work. So to enable them to focus on building rather than fixing or maintaining, so to continue to deliver business value to the organization, and adopting tools and vendors, whether across the board, if it's observability, tracing solution, understandability solution, all the stack trace, to give the engineers, which are kind of the most significant cost centers for enterprises, the ability to focus on delivering business value to the organization. So this is kind of the trend that we're seeing, which especially around the development areas.
Sure. Thank you so much for taking time out and talk about understandability, observability, and the whole ecosystem. And I look forward to talk to you again soon. Thank you.
Thank you. It was my pleasure.